Hello, calculus students. So I thought of actually creating a small video tutorial to just to get you started on the practice problem sheet, right? And so let's do it, okay? So I'm gonna just so this is a practice problem sheet. So if you look at the first problem, it's a limit problem. So, and that's using the limit laws, right? And so this looks like a quotient, but you have to be careful because if you cannot use the quotient rule if the limit of the denominator is zero. So if you take the limit of the denominator, you will get zero, and the limit of the numerator is also zero. You have zero situation, which is called an indeterminate situation. In which case, the only way out is for you to factor the top and the bottom and to see whether you can cancel a factor, right, which will help you to then, after that, use the quotient rule. Okay, so that's the approach for that. And but if you can use quotient rule from the very beginning, go ahead and do that. Okay, but that's not so in this case. So if you look at this, so you need to find the tangent line, right? So any equation, it's for the line is y minus y1 is equal to m times x minus x1, right? Okay, and you know what this is. X1 is 4, and then of course you can plug in this and find y1. Okay, but what is m? So m is the slope. So actually you can write this as m is the derivative, right? The slope is the derivative. So derivative at what point, right? At 4 and x minus 4, and this is whatever that you get from here when you plug in x equals 4. So you need to find the derivative using your derivative rules, right? Okay, and then plug in 4 and then find the derivative, and then it's a matter of plugging in that after that. So in this particular problem, you want it to be continuous. So now you can see that the only tricky point is x equals -1. When x is not equal to -1, you have a polynomial over a polynomial rational function which is continuous, right? So the only tricky point is x equals -1. So in order to assure that it is continuous, we need to show that the limit extends to -1, right? Okay, if h of x is equal to h of -1. And we know what h is -1, and that is from here with a. But what is this? Well, you need to find the limit of this because that's the one when h is not equal to -1, right? So to find the limit of this fraction, you can use the same technique as we do in number 1. So you can find the limit and set it equal to h of -1, which is a. That way you can solve for a. All right, so this is a straightforward use of the differentiation rule. So what you do is you differentiate this and then you plug in x equals 4. So when you differentiate this, right, rather than use product rule and chain rule, you notice that this can be simplified as x to the 3 halves. And also this can be simplified as 1 over square root x is actually x to the -1 half. So 8 times x to the -1 half. So if you write writing like that, things become so much easier because then you are not using product rule or chain rule, and you just differentiate and plug in x equals 4. Number 5 is just like number 1. So number 6 is also like number 1. You'll see that you get a 0 or 0 situation, but in order to do that, you might remember, that we learned a technique when you have a radical, right, at the bottom like this. What you do is you multiply the top and the bottom and the conjugate of the radical. And what's the conjugate? It's like, so if it is square root x minus square root 3, the conjugate will be square root x plus square root 3. So you multiply both the top and the bottom. So remember that when you have these radicals in these limit problems, you multiply the top and the bottom by the conjugate, right? And then, once you do that, the bottom is a difference of two squares. So you will see that actually the bottom gets cancelled off with x minus 3, right? And then you can just, after cancelling the x minus 3, you can probably use the chain rule, okay? So here's a limit problem from graph. So remember, so you want to find the limit. So there's a left limit and the right limit and the limit. So the limit, for the limit to x is right, whether you go from the left and the right, you should go towards the same point. What happens at that point is not important for the limit, but where it's heading is what is important, okay? All right, so 8 is you need to find the derivative and then plug in 1, x equals 1. But how do we want to find the derivative? This is a quotient, use the quotient rule. All right. So once again, this is another limit problem. Again, you look to see what happens when you approach from left and right, and if they're going, looking as if they're going towards, not touching, going towards the same point, that would be the limit if it exists. Okay. All right. So this is the limit definition problem. So for that, you cannot use any limit roles. You need to use the definition, right, which is, so remember, when you say you must limit the limit clause, you are not allowed to use the rules. You need to use this definition and simplify that and find the limit, okay, using the limit, okay. So now this is again very much, pretty much is a radical problem. So you multiply, you do it the same way as you did question number 6, okay, where you have a radical problem and find the limit, right? You multiply the top and the bottom by the conjugate. That will be the way out, right? Okay. So this is a graph of f, and then you want to find the graph of f prime. So how do you do a problem like that, right? So first of all, you look at the graph of f, right, and find out where the derivative is 0. So if you find, so you can see that the derivative is 0 here for one thing. So that is at x equals whatever, right? Somewhere here, x equals maybe 2 or something. I don't know, right? The derivative is 0. That means what? Right? Because the horizontal tangent derivative is 0. That means if you look at the derivative graph, right, that means it has to cut the x-axis at this point. So look for a graph which cuts the x-axis at that point. Now on the other hand, now here you see at this point, right, the derivative goes to infinity from left and right both, right? You get a vertical tangent, right? So that means the derivative function should go to infinity at whatever this point is, -1, right? There has to be it has to go to infinity, right? Okay, and then between -infinity and -1, right, and from 2 to infinity, you can see that the original graph is increasing. That means the derivative graph has to be above the x-axis up to -1. So for example, right, I mean, if you I mean, up to -1 it has to be above the x-axis, and after -1 it has to be below the x-axis, right? So if you, something like this will not work. Why? Because even after -1 it's still above the x-axis. It has to be below the x-axis after -1. Okay, so from that, and then again it has to be below there because it is f is decreasing, right, between 0 and whatever this 2 is, right? Okay, so that means the derivative is below the x-axis from 0 to 2 also. So you look for something where, so it definitely can't be this, because from 0 to 2 it's above the x-axis. Definitely can't be this, definitely can't be this. So like that, right, you can find out, right, okay, where it it uh, it goes below the x-axis from 0 to 2, right? Okay, and you will see that you don't get too many choices. You can get the answer quickly. Okay, all right, so that get used to. So look for the places first of all where the derivative is 0. That means horizontal tangent. That's where it cuts the x-axis, right? And then look for the place where the derivative is positive. That means the derivative is above the x-axis. The function is increasing. That means the derivative is above the x-axis. And look for the places where the function is decreasing, where the derivative is below the x-axis. Okay. So now this is so you want to find out where the is horizontal tangent. Horizontal tangent, in other words, means the derivative is 0. So what you do is you can use the derivative laws, right, to find the derivative. That is very easily, right, and then set it equal to 0, solve for x. Okay. Um, and so let's see. So here again, you need to, so now it's not, you want to find out the places where the derivative is parallel to the line y equals 2x. So you find the derivative, and if the derivative is parallel, is the curve is parallel to the line 2x, that means the derivative, the dy over dx, has to be equal to the slope of this curve, which is actually 2. So you find the derivative and set it equal to 0, solve for x, and do that. Another, this is number 15 is a co-chain rule problem, exactly like what we did in 8. Okay, so use the chain rule, right, and find the answer. Okay, and so then here's a trick problem. So remember, for the exam you need to find, the derivatives of these trig functions: sine, cosine, tangent, secant, and cosecant and cotangent by heart. Okay, so remember those derivatives by heart. Derivative of sine x is cosine x is negative sine x, derivative of tangent is secant squared x, derivative of secant is secant x tangent x, like, and so on, right? You need to find the you know the derivatives by heart, and once you know that, it's very easy to do this problem using derivative rules. So do you want to find the line tangent to this, right? So again, you can use that same formula that we used in what is that question that we did at the beginning, right? Somewhere, right? Okay. Number two, right? Okay. So this is very much like number two. Okay. So to find the equation of the tangent, so find the derivative and just write the equation of y minus y1 is equal to f prime or whatever the point. So the point is pi over 3, right? X minus x pi over 3, and then that is this point, right? Okay. This point slope from and find the answer. Okay. This is another problem exactly like the one that you did below. So you don't have to use chain product rule or quotient rule, right? Okay, because you can write this as powers, right? And then use a sum rule to do that. Product rule using you can use product rule here using the derivative of trigonometric functions, right? Now this is an implicit differentiation problem. So how do you do an implicit differentiation problem? You differentiate all the x terms, the only x terms, the ones which include x terms, you just differentiate as usual. For example, the x3, differentiate both sides of this equation. On the right hand side, you differentiate, of course, you get 0. When you differentiate something like x cubed, you get just 3x squared, nothing else. But if you just differentiate a y squared, then it's 2y, but you need to multiply by dy over dx. What if you differentiate something with x and y both? Then you need to use product rule, right? But when you use the product rule, whenever you differentiate a y term, you need to multiply by dy over dx. But if you just differentiate an x term, you don't have to do that. It will be just the derivative, okay? And then once you differentiate this side and then set it equal to 0 on that side, write the derivative, and then you collect the dy over dx terms and you solve for dy over dx, and then one of these answers will come out. So this is actually a chain rule problem, right? Okay, so if you look at this problem, right, okay, you will see that from the outside you only take the power rule, right? Because this is a 1/3 power, right? Okay, 1/3 power, right? Okay. So what you do is you use chain rule, so it'll be 1/3 to something, 1/3 to the just some junk, right? Okay, times 1/3 minus 1, and the junk is whatever that is you have inside, right? Then you find the derivative of this junk, t to the 3 minus 1, and you multiply that, right? Okay, and then once you do that, and you multiply that, you should get the answer. It's a matter of simplification. So remember, first of all, right, you don't see what is inside. So you take the power rule and take the derivative of the junk, right? Okay, and you get 1/3 minus 1 times 1/3, whatever this thing, and then you multiply by the derivative. A chain rule problem. Once again, here it's another chain rule problem. Remember, when you look from outside, you don't see the 1 plus cosine squared is, you only see the 6. So you have 6 times 5, and then you multiply by the derivative of inside. Okay, and then you need to plug in pi over 4, for which you need to use the unit rule. You need to have the unit circle. So remember the way I told you to how to memorize unit circle and then plug in. So this is an important problem. Make sure that you do it right. Okay, and this is again another problem like what I discussed earlier, where you're given the graph of f and you want to find the graph of f prime. Another chain rule problem, right? Okay, so chain rule is again from outside. You don't see this. You only see square root of some junk. So that is some junk to the power 1/2. So the first thing is you take 1 negative to the 1/2, and then you go inside, and then you see this, and you take the derivative of x plus square root x, right? Okay. So that's how you do that, and then you simplify, you get the answer. Um, Again, this is a continuous function, right? So you want to find out whether it's continuous. So in order to do that, you need to do what? To find out the tricky point. So there is only one tricky point, x equals 1. So you need to make sure that the limit at x equals 1 exists, right? And you want to set it equal to 4. to because the value of x equals 1 is 4. So you want to set the left limit, right? That is this approach, the top branch, right, is the left limit equals the right limit. So one equation will be the left limit has to be equal to 4. The other limit equation will be the right limit has to be equal to 4, right? Okay. And the right limit is this, right? Okay. This is the right limit, this is the left limit. So they have to be equal to 4, right? Okay, at x goes to 1, right? Okay, and then you can find, you get two equations. When you solve those equations, you can find C and M. All right. So once again here, what value should, so you need to find the limit of this function. So at 1 is the only critical point, so only important point. So the limit at 1, right, which you can find by setting the left limit equal to the right limit, right? Okay, and that has to be equal to the value at 1, right? Okay, so if you find this limit, right, by taking the left limit and the right limit, right, and set it equal to 1, you can find f1. All right. So that is a good quick review, right? And I want you to do this over the weekend. And if you have any questions, get back to me. Okay. All right. Good luck with the reviewing. Good luck with the exam.